Welcome back. In the last video, we looked at some photos from inside the mass spec and talked about, well, I talked about what the different parts do, kind of. So just to recap, we have ions that have been, we've got molecules being separated on the HPLC, and they come to this ion source of the mass spec and they get ionized. Now they can be manipulated in electric fields and they have a journey through the mass spec. And in the basic case, they collect in the C-trap, they get injected into the orbit trap, and we read out some data. And this is the kind of data that actually comes from the orbit trap. If you remember, I said that the individual mass-to-charge ratios form discrete bands that travel up and down the axis of the orbit trap. And then this causes a voltage across the two halves of the outer shell, which can be read off. And it gives you a signal to time graph like this. And then somehow we need to translate this. Actually, we don't need to translate it. It's done on board by a computer. This is not something that we have control over or really want to have control over, to be honest. But there is some signal processing that happens within the mass spec on the computer inside the mass spec that results in this being turned into a mass spectrum. And so in a mass spectrum, what we have is mass to charge ratio along the bottom and intensity, signal intensity up the side. And there are some really nice videos that I recommend you go and see. If I was giving this talk in the lab, then I would show people these videos for sure. The first one is a thermo-Q exactive video, which is from the vendor of the instrument, and it shows the journey of the ions through the instrument for various types of mass spec experiment. And it gives you a really nice feel of exactly what's happening in there. And the second is 3 blue 1 browns. But what is the Fourier transform? A visual introduction. And this is a really, really lovely piece of work, I have to say. So the Q exactive video shows you the journey of the ions through the mass spec, but it gives you a nice animation of it, how these discrete bands generate this complex waveform. And what the 3 blue 1 brown video shows you is how that complex waveform can then be decomposed into its individual frequencies. And it all comes from this relatively simple idea of winding your intensity versus time graph around a circle and then measuring the center of mass of that circle, of the wound curve. As you change the winding frequency. So if that doesn't make sense, yeah, fair enough. You need to watch the video. It's awesome. It really is very good. So these are, let me see. That's this one. So essentially, I don't know if I can draw on this, can I? No, oh, that's a shame. I'll flick back to the other one. Okay, this part here is just like the information that comes straight out of the orbit trap. This thing here is the mechanism by which the Fourier transform works. And this part here is just like the mass spectrum that we end up looking at. Highly recommended. And we'll leave it there, and I'll see you in the next video.